Welcome to the HERD project. HERD stands for the HLS, ECLS, Research and Design, or more brought out, it's the Human Landing System, Environmental Control and Life Support System, Research and Design project. And that is this. This was the goal of the semester, was to build a environmental control and life support system test bed. The mission of this semester was to obviously design this, but to remove carbon dioxide and humidity from a flow stream, which would mimic a simulated environment for the HLS.
Hi, my name is Cody, and I am in charge of the lab supply air. The lab supply air is in charge of supplying all the simulated metabolic outputs. It starts with the lab supply air, which is basically this atmospheric air coming into this flow meter and into our sparse humidity system, which we are able to control the amount of humidity that is input into the system. The air can either go into the actual sparse humidity system where it is then humidified and we are able to control that through a needle valve, or it's able to go into a bypass just basically for dry of that air. It is then going into these tubes, which then is inputted into the rest of the system.
That's way more reasonable. So now turn it up to where I think we had it. So just keep going, and I think it'll be bubbling way more intensely. I'm Nathan Foote. I'm the systems engineer for the HERD project, and I'm also the humidity removal subsystem lead. So the two things that I was majorly in charge of were the overall system design through systems engineering and the humidity removal subsystem. So I'll start off by going over the overall system design. Air comes in to our system that is humid with CO2 content in it, and then it goes into our CO2 removal subsystem. And the air, hopefully scrubbed to CO2, is sent in through a temperature and humidity sensor and a pressure sensor. And then that air is sent over to the humidity removal subsystem, which is a Nafion bundle, which removes the humidity through a difference in partial pressure of water vapor between the airstream and a vacuum line. And then the returned air that has no CO2 and hopefully that just the correct amount of humidity has a dew point sensor, pressure sensor, temperature relative humidity sensor, and then is vented through a flow meter into the atmosphere.
My name is Chad Flieger. I'm the project manager and the engineer responsible for the carbon dioxide removal solution. In this case, this is the lithium hydroxide that would be enclosed in this 3D printed box. That essentially the air will flow through with CO2 into this cavity, and through these holes there will be ports for, there will be CO2 probes mounted on the inside, as well as thermocouples coming through the top here to measure temperature. Thus, when the air moves through the lithium hydroxide, it will react with the lithium hydroxide and create lithium carbonate and water as a byproduct, and will be coming out the back end, which will be monitored again for CO2 and temperature.
Hello, my name is Sam. I am the test engineer and data acquisition subsystem lead. For our data acquisition subsystem, we have provided pressure sensors, relative humidity and temperature sensors, dew point sensors, and flow meters throughout the system at different key points. All of these sensors run back to a central hub where we route the data into a National Instruments data acquisition system, which runs into our workstation, and we can collect that data and store it using LabVIEW.
As it currently stands, we are at phase 2 of 5 for the testing, which means we're going to actually be bleeding off into the summer to complete this project. Our data will be scalable to help aid virtual habitation models improve their fidelity as well as their verification and validation cases.